All right. Welcome to another episode club where we are going to be discussing a couple Expanse episodes that I'm very excited to talk about. We've been talking primarily about Star Trek in this episode club, which is understandable given my association with Star Trek, but also the there's a lot of crossover fans and there's a lot of science in Star Trek and some really iconic episodes that we wanted to talk about. But my patrons, at which you can find the link down below, voted for 2 Expanse episodes to talk about this week. We kind of had this generic discussion about talking about the Expanse in general, and then we thought about some of the iconic scenes that people wanted to talk about. And primarily it was the Epstein Drive that we want to discuss, and then that scene in the Expanse episode where the tools are flying all over the place. So we decided to talk about first Paradigm Shift, which is season 2, episode 6 of The Expanse. If people are watching and they haven't seen any of The Expanse, I mean, it was a spoilery jump in. If you've seen it's not a very episodic show. It kind of follows a story arc, which is great and makes it for great viewing. But I feel like these are actually really good standalone episodes. I have watched The Expanse all the way through. I jumped back and watched these 2 individually, and I felt like it was kind of good, sensible reminders for what had happened without being too out of context. So this first episode, it's called Paradigm Shift, and it opens with 137 years ago from where the Expanse is taking place to when Epstein was first developing this drive. And up until now, we have just heard of this method of traveling through our solar system, and they have referred to it as the Epstein Drive, but we didn't really have much more context other than that. And one of the things I love is that the Expanse uses a type of artificial gravity that we haven't necessarily seen a ton of in science fiction, which is to do linear artificial gravity. Most realistic, not breaking science artificial gravity that we've seen in science fiction has to do with rotational artificial gravity, which we've seen in The Martian, we saw in 2001 Space Odyssey, we've seen that in Mass Effect with the Citadel Presidium, all uses rotational artificial gravity. So it's this idea that you utilize centrifugal force, which is something I'll talk about when we get to the next episode. But the linear artificial gravity is basically saying, all right, we're going to build our ship kind of like this, that the platforms are like that, and then it's going to fly through space, and it's going to accelerate at 1g, or about 10 meters per second every second. And that is the acceleration on Earth due to gravity. So if I drop something on the surface of the Earth, it's going to fall, and it's going to accelerate its speed, meaning its speed is going to increase about 10 meters per second every second. And because it's kind of my job to get into the painful details, the beautiful and yet somewhat painful details about the science behind this, we're going to really break it down. Now, Epstein, like I said, this flashes back to kind of the development of this Epstein Drive, and we get this hint that, he's picked up this, he's from Mars. This is currently where it's the United Nations Mars colony, so they're not an independent government. They're still part of the United Nations, and he says that, they're in the state where everything they're mining, everything they're building is being sent to Earth still. And that all makes sense. There's no science there. But he gets this yacht. He says he got like a secondhand yacht, and he's trying to improve. He's a fusion drive engineer, and so he's modifying the engine to boost the fuel efficiency, and he's expecting like a 4% increase in fuel efficiency. So this is the rate at which your fuel burns. Fuel efficiency is effectively how much fuel you have compared to how fast you're able to go. And this is the interesting thing. We're going to do some Physics 101. And sorry if you haven't taken physics in a long time, but that's what you're here for. So we are going to talk about the difference between position, speed, and acceleration. And that's very important to this episode, but it's important to science fiction travel in general. So I talked about if I drop something here on Earth, it's going to accelerate 10 meters per second every second. Now, that is due to the pull of gravity. Earth's mass is attracting things. These are all kind of associated words that kind of work with it, but it's attracting things at about, that fall to it. They increase their speed 10 meters per second every second. Now, that we always have to be careful when we say the acceleration due to gravity. It's Earth's mass that's pulling things toward it, and they accelerate when they fall. But now let's take a step away from gravity and just look at acceleration itself. We start with a position, and then when you change your position over a period of time, that's a speed. So you might be walking at 2 meters per second every second. Probably more like 1 meter per second every second. Or 1 meter per second. And so you're having this fixed speed. You're constantly moving through, and you're going at 1 meter per second. If you want to increase your speed, then you accelerate, and you increase your speed over a period of time. So maybe you start running, and you increase your speed within 1 second from 1 meter per second to 3 meters per second. In 1 second, you have accelerated 2 meters per second every second. You still with me? Do you want me to say meters per second again? Because I bet you don't. And that's okay. But the important thing with this is that Newton's law of gravity says that in order to accelerate, you need a force. You need something that's going to push in order to increase your speed. That's the F equals ma. Some of you might remember that. So force equals mass times acceleration. If you want to accelerate a mass, you need a force. And that's what's really important when we talk about space travel. And it's something that we forget a lot here because we have our Earth laws are kind of sometimes impede the way that we view physics and we view the world. So if we're accelerating in space, that means we're going to need some force. We're going to need something to push the spaceship so it accelerates. And once it gets to the speed that we want, you can switch your engine off, and you will keep going at the speed that you hit, and you're not going to stop because there's no air in space. So there's no friction. There's nothing that's going to slow you down. And that's Newton's first law, that an object in motion will stay in motion and an object at rest will stay at rest. If there's nothing acting against it, it's just going to keep moving at the speed that you were at. But if we want to simulate gravity, bodies have to be accelerating. So these ships, this Epstein Drive, accelerates at approximately 1g, 10 meters per second squared, or 10 meters per second every second. In order to have that acceleration, that means the ship has to constantly be accelerating. It's always burning fuel. So that's really the key here when we're talking about the Epstein Drive, that what he was doing is he was trying to find a way to increase fuel efficiency so he could burn fuel for a lot longer, that would allow you to go further and faster in a reasonable period of time. Because if we were to try to build something like that now, where we said, all right, we're not going to worry about building a rotational spaceship for artificial gravity, we are just going to accelerate our ship at 10 meters per second about Earth's gravity towards Mars, we'll get to a fixed speed, we'll flip the ship around and decelerate in the other for the rest of the journey and experience Earth's gravity throughout that. You're going to need fuel for that entire journey to keep speeding you up and to keep slowing you down. And that's the really, really hard thing. So what happens to the gravity when they stop accelerating, they're still moving it in space, whatever speed that they were at. Once they switch the fuel off, once they switch the engine off, then they start to experience 0G, which we've seen, and I'll talk about it in a little second. So regardless if they are stopped completely, if they are not moving, or if they are moving but at a fixed speed, if there's no acceleration, there's no gravity. And that's really the key here. That's the hard thing to wrap our mind around. But for a drive like this to exist, if we as humans were going to make that, we would need to drastically increase our understanding of how fuel consumption and sources of energy any sort of fuel, we would need to increase that capacity, that science, much, much more. So that's really the key when it comes to having artificial gravity that is linear. One of the things that I love about this is that it allows you to travel within your own solar system. If we get to the point, as Epstein did, where he built a engine that was fuel efficient enough to reasonably travel through our solar system in not stupid periods of time, if we were to just accelerate outside of our solar system and continue increasing our speed as we go over and over and over again, if we keep increasing our speed, there is a limit to how fast we can go in space, and that's the speed of light. Nothing can go faster than the speed of light. And you hit the speed of light, if you're accelerating at about 10 meters per second squared, constantly out of our solar system, you hit the speed of light at about the edge of our solar system, about almost exactly 1 light year away, which kind of blows my mind. And I keep wanting to go back and check the math on this, and I've checked it a couple times and it still checks out. But it's weird that it works that way, because that's not like just universal laws of physics. Our Earth, it's dependent on our Earth's gravity. Like our Earth, our planet, the acceleration due to gravity is 10 meters per second squared. And for some reason, if we were to accelerate at 10 meters per second squared, we would hit the speed of light at 1 light year, which is the edge of our gravitational influence. Weird. Crazy numbers. But anyway, that's kind of an aside. The whole point of this episode is showing how Epstein developed this drive. And basically what he did, they don't really go into the science a ton, but he increases the fuel efficiency to an insane rate. And again, they don't necessarily explain how, but they've made it incredibly fuel efficient. So this ship is able to continue burning fuel, which again is your force that is constantly accelerating your ship. That's the breakthrough. And that's the story that we're trying to tell here. Now, there's some humor in here and some of the non-sciencey fun things aside with this. This actor who played it, Sam Worthington, I didn't write it down, but he is the main character in Fanboys, which is one of my favorite movies of all time. If you haven't seen it, check it out. It's about Star Wars fans trying to break into Skywalker Ranch, and I love that movie. But I was like, I know that guy. That's what I know him from, because I've watched that movie a lot. Came out in 2009. It's an awesome movie. Aside from that, when they show the dashboard, which always gets me excited as a scientist, because I'm like, all right, let's pause. Let's see what we got here. And they show a speed in MPS. Now, initially, my brain, I don't know, for whatever reason, maybe because it was a speedometer, I was like, is that miles per second? It has to be meters per second. And they show him at a fixed speed at the beginning. He's kind of coasting at about 5,500 meters per second, which means he is at a fixed speed, but he's not accelerating. So in his ship, he's strapped down, so you can't really tell, but he would be experiencing 0 Gs. Now, he fires up this drive, and it starts to increase 100 meters per second every second, like hundreds. And so I was like, well, but he's not going 1 G. And again, he's not trying to simulate Earth's gravity necessarily. He's just trying to test out the fuel efficiency of the ship. But they also have a meter on the dashboard that is indicating how many Gs he's experiencing, which is how many multiples of Earth's gravity the acceleration is. So if it's 2 Gs, he's experiencing 20 meters per second every second of acceleration. And so you have these multiples of Earth's gravity. And what you see is it's not just the speed that's continuing to increase, but you actually see the G's increasing, which means your rate of acceleration is increasing. So what's that? Why have we never heard about this stuff before? Valid question, but what it essentially is if you go from, I'll try to do it this way. I don't know which makes more sense. I'll go from it this way. You go from position to speed to acceleration and what's called jerk. And that is how quickly your acceleration changes every second. Yeah, it is worth watching. If you did watch these 2 episodes, you were probably a little bit lost, but they are entertaining. But what we're mostly talking about here is their method of traveling through our solar system, which is constant acceleration through space. So if you see his G meter, what's indicating how many forces of G he's feeling, that is starting to increase, which means he's burning fuel so fast that he's experiencing jerk, which is harder on the body, and a change in G forces. Like I said, we don't really talk about it a ton because we normally just go from position, speed, acceleration, but jerk is change in acceleration. And so when you are, let me try to think of a good analogy for this. If you're in a car and you are going at a fixed speed, if you want to increase your speed, you press down on the accelerator, a little key word there, and that starts to burn more fuel, which accelerates your car. But if you are trying to continually increase your acceleration as well, that you want to just not have that speedometer go up at a fixed speed, but actually have it start to do that, then that's jerk. I know it's kind of hard to wrap our brains around, but physics is fun. Now, I want to just step aside from the Epstein Drive because we're going through this episode. I will say I love when they are sitting around in the United Nations Council trying to figure out what happened with Eros. This is an aside for people who haven't watched The Expanse, but they were like, I'm glad you're enjoying it. So they were like, was Eros a test of Martians' zero inertia drive? Or was it some sort of massive relativistic field generator? And of course, I'm like taking notes, and I'm like, this is nonsense. And then immediately, Avasarala, who is an amazing woman and an amazing character, was like, or it could be some other bunch of science words that you're randomly stringing together. I was like, yes, you go, because she's amazing. All I wrote was, love her, with lots of exclamation points. Anyway, they're trying to figure out what happened, and as it's flashing back and telling the story of Epstein as he has discovered the Epstein Drive, part of the other story that they're telling is that Earth fired a bunch of missiles back when this whole thing was happening that they're wondering about, and they were able, so everyone kind of panicked, they fire 150 missiles, and then everyone starts to calm down, and they self-destruct, they detonate. But they only got a confirmation of detonation on 121 out of the 150 missiles. So that's not good. So 29 missiles are unaccounted for. They've lost the target lock on them. They don't know where they are. And I think this is important because if they were completely to shut down and didn't detonate and didn't get a confirmation, that would be really hard to track them. Let's imagine that they fired these missiles, right? And they have, remember, force equals mass times acceleration. They are using fuel to accelerate to a speed to get to their target. Because we have these drives, possibly have some sort of massive fuel efficiency on these rockets, they might be able to accelerate for a long period of time. As they're accelerating, they're burning fuel. That would give off a heat signature that would be able to be tracked easily. If they just go dead, if they run out of fuel or they were tracking, maybe sending out a beacon to say, here's where we are, here's where we are, here's where we are. If that disappeared and they weren't giving off fuel, then they're just dead in the water. They're not giving off any signals. Yeah, you'd be in trouble because space is really big and cold. And the most you might be able to get is residual thermal energy from these missiles. As they're giving off heat, they would be radiating infrared radiation. So think about it like Predator, right? Predator can see in the infrared. You give off this heat that you might be able to track, but missiles are really tiny and space is very, very big. So it would be very hard to track these if the fuel has run out and they're not giving off any tracking beacons and you didn't get confirmation of detonation. You'd be in trouble and you wouldn't be able to figure out where they are. They do a great cutscene to all of these rockets moving away from Earth, and there's a massive net behind them. So all these rockets are coming towards, and there's a huge net blocking their signature. So you can see that they're still giving off fuel. They're still burning something. but they have a big net behind them. For whatever reason, the brilliant thing that made me think of is like a Faraday cage, right? Faraday cages are a way that we can block electromagnetic signatures, mostly used when you are wanting some sort of quiet zone. So if you want to block that electrical hum or that sort of heat or radiation that's coming off of electrical systems, you build a Faraday cage and it blocks all of that. So you see them a lot in physics departments. When I observed at Green Bank Telescope, they had their observation deck was in a Faraday cage. And all it is it's just a net of webbing. And it basically just screws up and dissipates all of the electromagnetic signals so it doesn't interfere with stuff. And that, for me, was exactly what they were doing when they captured these missiles. They just throw a big web of probably metal behind that. And so even though these missiles are still giving off electromagnetic radiation in the direction of Earth, they would see a signature, but it would all be masked and it wouldn't be able to be identified as a missile. So I love that. It's really cool. Now, it cuts back to Epstein at this point, and we get another shot of the sensors. So let's science the sensors. We are now at 4G, and that 4G is increasing about 0.1 Gs every second. And we're watching the meters per second increase about 1,000 times. So he's now up to 10,500 meters per second, and that is ticking up. So it's like 10,005, 10,006, 10,007. Not good. It doesn't totally correlate to the Gs, but the Gs are increasing, so we would be getting some like crazy exponential increase in speed. I tried to do the math, and then I started to get a cluster headache because dealing with jerk to speed is can be a little tough, and the numbers were going so fast it was hard to track them. Anyway, we didn't get a ton of that, but that's okay. But he's experiencing 4G, so he's feeling heavy, right? And he even says he's feeling heavy. Starting to increase. We're starting to get up. You know, by the time he's done talking, you can imagine he's probably at 5 or 6 Gs. So 5 Gs is about the most you'll feel on a roller coaster. So you'll feel a quick acceleration. You get pressed back into your seat. The most they try to aim for, like, no more than 5. 5 is not good, and you would only want it for a split second. So that's usually like if you're going through some really quick acceleration or a quick stop or just a quick turn, then you might feel those Gs. Fighter pilots vertically have experienced, they are trained to experience up to 9 Gs. But the whole body, the human body, is very sensitive in different directions. And I'll talk about that in the next, when we get to the next episode in a couple minutes. But 9 Gs, that's like fighter pilot training. And they said, you know, some humans can handle it. Some will pass out at 6 Gs. Some will pass out at 3 Gs. Some people's bodies are all very, very different. And so it depends how we're able to interact, what we're able to handle. So he's kind of now at, you know, he's uncomfortable, but he is still okay. But he makes the sentence that if the issue with experiencing high Gs is that you will die if you have to handle it for very long. The main reason is because our bodies are fluid sacks. As disgusting as that is, our bodies are sacks of fluid, and that means that fluid moves around. And so when you have these acceleration, because of inertia, our body wants to stay in the same spot and our fluid wants to stay in the same spot. And so as it's accelerating, it keeps trying to stay where it was. And so what fighter pilots do is they're able to train their bodies to keep blood circulating. And that's really the key there. It's gross because humans are gross and squishy. But, you know, it is what it is. That's why I studied the stars. That's why I studied the gravity part of it, not what it does on the body, because that's gross. All right, so they do actually, there was a question about what happens to the gravity when they stop. Great question, because they do actually point out, as they're talking to someone else who's one of the belters, that they say they were tracking the main ship I mean, it is what it is. They were tracking the Rocinante, the sort of lead character ship, and they saw that they had cut thrust for 5 hours. So cut thrust means that they weren't accelerating anymore and not giving off a signature and hard to trace. They would be possibly going in the same direction, possibly have stopped, or the same speed, possibly have stopped, but the point is they're not accelerating. They've cut their thrust, so they have no signature coming off of them anymore. Why they're doing it isn't important because there's some people here who haven't seen The Expanse. Essentially, they found this protomolecule. They have a sample of the protomolecule, which is this weird substance that is like an alien substance, and the Rocinante has hidden it in an asteroid, which you briefly see this in the episode with them trying to decide if they should destroy it and send it into the sun, as one does. We are just big fluid sex. One of my favorite lines from Mass Effect Andromeda is when your Krogan buddy basically says, "Humans are bold for being so squishy. Don't you know you're mostly water?" That's one of my favorite lines ever. But yeah, it's important to keep a note that the fluid in our bodies does not do well at acceleration. Okay. So it cuts back to Epstein. He's now like doing this calculation. He's accelerating into space. He's held back, like his arm was up when he took off, and so it's like pinned here. And he's saying that, you know, at this rate of exactly meatbags, at this rate of acceleration and the fuel efficiency, you can see how much fuel he has left. He's been burning fuel now for at least dozens of minutes, and he's starting to push 10 Gs. And his fuel is barely ticking down. And remember, fuel efficiency basically just says that it's directly proportional to how much fuel you burn. So, yeah. I mean, we can pontificate on the human existence. I like to call us cucumbers with anxiety. That's my other favorite one. So, I did try to do some math here. This is the scene now where his wife is trying to get in touch with him. So, he's like, I'm still accelerating. My G's are increasing, so it's not even just hard to move now, it's getting harder and harder to move, and I can't reach anything to cut this engine. And then he has a message that buzzes next to him, and so he's trying to reach that and get a hold of his wife. So that's what's happening at this scene. And then basically he's up to now about 350,000 meters per second, which is, now we're talking about fractions of the speed of light at this point. I mean, it's fractions. It's like, it's under I think 0.1 is what it would be, the speed of light. But that's a problem. 0.1 times the speed of light. Yeah, that's not good. Das ist nicht gut. So, 0.1% the speed of light. So he's booking it. He's continuing to increase. He's at 10 Gs now. But again, the G's are increasing, so he's experiencing jerk, not just acceleration. And again, tried to math it. The numbers didn't quite check out. I did figure that if he's at 10 Gs, let's just say he got fixed at 10 Gs, that means he's accelerating at, I think it just means 100 meters per second per second. The time that he spent trying to get his messaging thing, let's just say he was fixed at 10 Gs. The speed, because we could see the speed change, works out to about 291 seconds, which is 5 minutes. So he spent 5 minutes trying to get this, constantly accelerating. Once he gets a hold of it, he's out of range. So the signal is not able to reach back. Now, the signal would be sent out. But the point is that they effectively are saying that there's a time delay at that point that is unreasonable, which kind of makes sense, kind of doesn't, because if you send signals out, they are just going to keep going. For a lot of comms, it might just be that out of range means you sent a signal out and it just loses energy, so it can't be picked up by maybe a relay station. It would still reach Earth, but you would need a station that's able to pick up that signal, if that makes sense. That's kind of how I read that. So he's so far away that he can send out the signal, but it'll dissipate and it loses energy that by the time it reaches a relay station for his wife to pick it up, then it's already out. So not good. Let me see. It keeps flashing forward. Now so this was the scene that we just had. He had been going for an hour. Then it flashes to him being over 4 hours, and he's going 3 million meters per second, which is 3 times 10 to the 6th, and the speed of light is 3 times 10 to the 8th. So now he's 1% the speed of light. Oh, not good. And I will flip really quick. So he takes off. Basically, the story with Epstein is that he invented this drive. His wife had the plans, he's had the plans stored, that his wife had access to them. When he took off, he was never to be seen again. Flies into the stars, which is really sad. Drive is still named after him. He's heading out, he's comforted by the fact that his wife will be great and that we have reached a paradigm shift, the titular phrase of the episode, in the Mars-Earth relationship, because now Mars has this incredibly fuel-efficient drive that will allow them to explore the solar system in a very efficient and effective way. I will talk briefly about Ganymede, because it ends with Epstein flying off into the stars and then pans down to Ganymede, which is one of Jupiter's moons, which we love. I talked about it on our episode club 2 weeks ago. And we love Ganymede. Ganymede is about the size of our moon. So it has about moon's gravity on it. It's about 1/6 Earth's gravity. And we have our Martian Marines on the surface. Now, if you did watch this episode and you had not seen The Expanse before, you would be lost with a couple things. But I will say, this was a cliffhanger that is so good that I was like, do I need to go to bed? Do I need to go to bed? I need to watch the next one. I need to watch the next one when I first watched it. Because it is really, really good. That they're on the surface of Ganymede, where we've set up Earth and Mars both have a presence on Ganymede doing agriculture. I mean, they keep talking about growing soybeans on Ganymede, which would be difficult. They do have what look like mirror displays that don't necessarily, they could be comm signals, they could be reflecting and beaming solar light, which is possible. But the sun is pretty small at Jupiter, so it's not getting a ton of energy there. And they do talk about the farming a little bit on Ganymede in other episodes, where they allude to, efficient farming and capabilities that they have. They do, the Martian Marines ship does say, we're out of visual range for 48 hours, but they do get some comm signature, which is, checks the box, because we do have kind of, for the same reason that you can hear your friend around the corner. Even though you can't see them, you can hear them, because sound waves and electromagnetic waves hit corners and they diffract. Diffraction. So that's what diffraction is. And that would kind of behave in the same way here, where you would still get some electromagnetic curvature of a comm signal. So, talking walkie-talkies. But you wouldn't necessarily be able to see them. Friend around the corner. Just think about that the same way. And that still works. So they lose visual contact with the Marines. They still have some comm signature, which does go out, but it won't go out for as long. I think they say they're out of visual range for 48 minutes, but they have a significantly shorter period of time where they can't actually communicate with them. At which the humans, or not the humans, the Earth Terrans, the United Nations military on the other side of the line is now running at them, and they're like, what's happening? And weird stuff happens, and I'll leave it at that, but it was really cool. Creepy and super worth watching. All right, so we're going to talk briefly now about the episode IFF in The Expanse, which is season 3, episode 2, so flash forward. We have learned about the Epstein Drive. The big takeaway from that is that if you want to have artificial gravity in space. The way the Expanse does it is it has linear artificial gravity, meaning your ship is constantly accelerating at about 10 meters per second every second, which requires a stupid amount of fuel, which the big boost in fuel efficiency is what allowed this to happen, what allowed this world to thrive that we live in the Expanse, the fictional land. So, the Expanse IFF, Season 3, Episode 2, opens on Io, and it pans down and it says, Io, parentheses, Jupiter Moon 1, which I love, because we talked about that, again, 2 weeks ago in my astronomy club, when we talked about the Galilean moons and how Galileo had them named Jupiter Moon 1, 2, 3, and 4. And it was actually another astronomer that had named them Io, Europa, Ganymede, and Callisto. And it wasn't until we started to discover more moons in the mid-1900s that we transitioned from calling them Jupiter Moon 1, 2, 3, and 4 to Io, Ganymede, Callisto, and Europa. Fun fact. So, pans down to Io now. So we were on Ganymede with the previous one. This is now on Io. And again, desolate world. They do a great job of making these moons desolate, because they are, and they would be terrible places to live. Io does have a lot of tectonic activity. It's the most geologically active object in our solar system, including Earth. And that's because it is in resonance orbit with the other Galilean moons, so it gets churned constantly. It's the pizza planet, if you remember that. It looks like a pepperoni pizza. So it's churned constantly. It would not be an ideal place to set up a permanent settlement, but to do some helium-3 mining and then abandon it when you got what you needed is possible. So this is taking place at an abandoned helium-3 refinery. Now, helium-3 is a thing. it's a form of helium, and it is found in our solar system. There are various uses from it. I have no qualms with saying that there's a helium-3 mine on Io. I don't know if that would be the best place to find helium-3, but it's possible. So, now, the main part of this episode, the main thing I wanted to focus on here, is not just the awesome scene that we saw at the end with the tools being loose, but also the fact that we have two characters, Bobby and Avasarala, who have just escaped in a civilian racing ship, and are being hunted down by a bigger United Nations ship. And they are in this tiny ship, and it's this racing ship. Now, Bobby is a Marine. Avasarala is a diplomat and possibly one of the coolest women in fiction ever. But she is not used to space travel, and she was not trained as a Marine. She is from Earth, and yes, she is trying to escape the United Nations. We don't have to get into the story why, but you did hear that right. Now, they're trying to escape the United Nations ship. If they want to escape, they have to increase their speed to get away from it. Bobby mentions something. She has a range on her sensors that says, this is the limit to which if they send a missile at us, I don't have time to evade it. Which makes sense. There is going to be, even in space, a range at which you are not able to evade and get out of the way or accelerate away from it. And that's really the big key, is that even if it has tracking, what she's saying is if she wants to escape this missile, you basically have to accelerate your speed fast enough that you get fast, that it can't catch up with you. And there will be a limit to what that ship can do versus what the missiles can do. And they have that automatically programmed in, which is very helpful. Now, Avasarala comments, she's like, what? I can't see, is this the best you can do? And she says, yeah, it's the best I can do with passive scanning. Yeah. Hardcore agree. She says it's the best I can do with passive scans. Active sensors would give us away. So this brilliant comment on active versus passive scanning. And it's something we don't really think about a ton. But if you are doing passive scanning, that means you just have a dish, you have a receiver, and you are taking in signals. So this is like setting up a telescope in your backyard. You are just taking in what the universe is giving you. If you are doing active scanning, that is more like radar, sensors, or sonar. So that is sending out a signal to bounce off and reflect back, and then you learn more about it. Active scanning requires the viewer, the person doing the scanning, to send signals and receive signals. And part of that is like radar or sonar, you're bouncing signals off so you can track something and learn more information about it. For example, it's much easier to triangulate something if you are able to control the rate at which you are sending signals to bounce off and then receive back. And so it would absolutely make sense that you would get some telemetry information from passive scans, but you would just be reading whatever your sensors can pick up from whatever that ship is giving off. You have no control over what you're able to sense. As soon as you start active scanning, that means you're sending out pulses. Now, because we're in space, we would not be using sonar because sonar is reflecting sound waves. We would be using radar, most likely, which is radio waves that are being bounced off of an object and reflected back. Radio waves are a low energy form of electromagnetic waves. They are not sound, even though sound comes out of our radios. We've just screwed everyone up with that. But radio waves are a form of electromagnetic radiation. So that's the important thing to think about. Now, so she says, I'm just passive scanning, meaning I just have my sensors up. I'm seeing anything that is giving off a signature, but I'm not sending anything out. They have this range that from which they can't escape a missile if it's launched at them. And they basically get within that range, but she stays dark. And she's like, if I move out of this range, they will see us because I will give off a signal, right? Again, from what we just talked about, acceleration requires a force, which requires you to ignite fuel, which would light up. So that if you're just silent, if you're just sitting in space, you wouldn't be giving off a signature, so you would be okay. This United Nations ship is doing active scanning, and indeed, they do end up pinging the ship and do scan it. So Bobby sends out a signal, an IFF, their IFF thing goes off. She sends out a signal from her suit. Because it's a racing ship, it didn't really have emergency transponder stuff on it, but Avasarala asked Bobby if her suit had that capability, being a Martian Marine. And she said, yeah, I'm equipped with an emergency wideband transmitter, but it's really low power and it's encrypted for the Martian network, so only Martians would be able to read it. So wideband means you would give off, we've talked before about frequency shifts or frequency ranges. Wideband means it covers a large area of frequencies, so more ships would be able to pick us up. This is like a wideband would be able to pick up a much bigger range in frequencies, but it's a low power, so it's not giving off a ton of stuff. Hi, thanks for joining. Good to see you. I think I have a lot of people here who haven't necessarily seen The Expanse, so I'm trying not to spoil too much of this, but it is cool stuff. So she sends out this low power signal that's basically an SOS that says they need help. And it is picked up by the Rocinante, which has been renamed to the Pinus Contorta, which we don't have to get into. There is a reason for that. But they're going to Io to find this guy's daughter. And he's on the ship with them. So if you did watch this, but you haven't watched The Expanse, that's the context behind it. They're trying to pick up the adorable kid May from there. One thing they're doing, which I really love, is because they're kind of an outlaw ship at this point, their filters, their air filters are starting to decay. So they are needing to set up some method for filtering the air system. So now that they have a botanist with them on the ship, who's this guy that they're finding his daughter, he's helping them set up basically hydroponics in their air filter system with plants that are efficient at filtering air. So that's pretty cool. And definitely something, this is like the subtle details in The Expanse that I really like, where you can see how they have utilized parts of the ship that you wouldn't normally necessarily associate they have used them for plants. So, like, for example, their table in the mess hall has plants growing underneath it. And that's okay. I'm here for 15 more minutes too, so you're more than welcome. So because at one point they mention that they need to, that they're burning fuel too hot and they have to fix it because they're going to run out of reaction mass. And the explanation that they give for this is that their drive signature, they need to mask. So they basically need to fire their drive in a way that it looks like another type of ship, which is valid. So these different types of engines that they build are going to give off different signatures. Think about it like different car engines, right? Which I know very little about, but I do know that different cars sound very different. And that has to do with the engine and the mechanics in it. And so while we kind of hear sound coming from different engines, you can imagine that a spaceship, different spaceships that are made with different types of engines would give off different signatures. And they're trying to make their ship seem not as capable as it is. So they're trying to burn dirty, is what they said. And that's burning through fuel. But they're trying to tweak the engine so it still gives off so it sounds grosser, basically, but it's not burning fuel in that nasty way. And then he goes, hey, the IFF is pinging. It's just picked up something. And he identifies IFF for us, which a lot of science fiction, especially military science fiction, kind of assumes viewers know. And if you haven't been in the military or interacted with it, you wouldn't necessarily know. But IFF is a thing, and it stands for Identify Friend or Foe. And it's basically a target recognition system. So in the way I was talking about picking up different drive signatures, IFF is a more active way of sending out a signal that can identify friend or foe. So you know that all of your pilot's planes have this transmitter that's going to identify them as friendly. If planes don't have this, or if they have a different signature, then that would be identified as a foe. So that's an IFF signature. But what he's picking up is the emergency signal, and because they, without getting in too deep in the backstory, there's Martian connections, he's able to decrypt it. Now, they get this, there's debate on what they should do, what they shouldn't do, if they should go help them or not, because they're on their way to Io. Spoiler, they end up going to help, which is awesome. And at this point, we flash back to Bobby and Avasarala, which I'm thrilled about because Avasarala is freaking amazing. And she is having problems because they're accelerating. They've seen them. They got scanned. Remember, the UNN ship is doing active scanning, so a little beam passed over it. Alarm bells went off. They have been scanned. They know where they are, so they burn, and they're trying to get out of there, and they're trying to accelerate away from that ship as fast as they can. So they're experiencing high Gs. Now, Bobby mentions she's been trained for this. Avasarala, diplomat, politician, has not been trained for this. So Bobby's trying to see if she's having a stroke, asking her if she's experiencing tunnel vision, all of these sort of things, telling her she needs to remember to breathe. All of this stuff is entirely valid. She's like, I've trained for this. I could do another 4 Gs, but you can't. And so she decelerates. So remember, they're still running away, but they're not getting faster. They're accelerating away at a slower rate. That physics, man. Now, I do love this. It's terms of science fiction battle scenes, this is one of my favorites, and we haven't even got to the main reason we wanted to watch this episode yet. But they are in this combat situation, right? They are in these like gyroscopes that's going on. So Bobby and Avasarala are set up here, and one in front of the other. Remember, this is intended to be a racing ship. And what it's doing is it's turning them like this, and their view screen stays in front based on where the ship is going. So it's almost like they're in an isolated pod from the rest of the ship. This is kind of an inertial dampener in the way that it's keeping them in the same position. Like inertia is your body wanting to stay in the same position. And I thought about this, and the reason is not just because it looks cool, but it's brilliant because the human body can sustain higher... Remember, this is a civilian racing ship. Human body can sustain higher Gs horizontally than they can vertically. And if your ship is moving around, you're going to be transitioning your acceleration across all different parts of the body. But if you make it so you rotate freely, so your acceleration is always horizontal, that's really healthy and good for you and correct. So the human body can sustain much more G's in a horizontal direction than it can otherwise. And as they're flying around, this G-force gyroscope thing that they're set in is ensuring that their acceleration is always in the horizontal direction. Bam! Love it. Brilliant. So, aside from all of that, she's still struggling. She's still not able. And Bobby tells her to clench her thighs, and she comments on if she's hitting on her because Avastral is the best and we love her. But Bobby mentions it's to keep the blood flowing, and that's exactly how fighter pilots train as well, is to make sure that the blood doesn't pool, because remember, humans are fleshy sacks of liquid. Now, the UN ship has fired missiles at them. The Rocinante has come and they fire missiles. The Razorback, the racing ship, doesn't know what's going on, but those missiles fly past them, detonate, and basically confuse the tracking system of the other missiles, causing them to detonate as well. As they are about to go into combat, when they do this, now we have our two characters down in the bay are like, oh, we got to strap in because we're going to depressurize. So when they're in combat, they depressurize the ship. Everyone gets locked in. They get set in their position because they're going to experience really high Gs. But the botanist didn't lock down the toolkit. And so as they're being jolted around while they're in space combat, this locker shoots open, and as they turn position, the tools fly in different directions because of inertia. And it looks amazing. And it is one of the coolest science fiction scenes I have ever seen. And I will talk about this all the time. But really, all the science behind it is inertia. The objects want to stay where they are, and the ship is moving outside of that, throwing for them, appearing to be thrown in different directions. The graphics for it are perfect. Even when they show him trying to go save the botanist, when his head gets disconnected, he's like falling in one direction and he's moving as if he is falling, and then the gravity changes, they accelerate in a different direction, and he appears to be falling in another direction right alongside with the tools. And so again, it is just inertia. All those tools want to stay where they were, and the ship is basically moving without them. It's the same idea that if you ever, this is against the rules, and I am a lawfully aligned person, but if you ever did one of those free fall roller coaster rides, if you let go of a penny in front of you, which I didn't do, but my physics teacher did in high school, and I witnessed it and was stressed out at the rule breaking happening from my teacher. But if you let go right when you fall, the penny will just float in front of your face because it's accelerating at the same rate that you are. So even though you're accelerating, as long as it's at the same rate, you're fine. When you're going against that acceleration, which is happening with the tools, they want to stay in the direction they were flying. Now the ship is going another way, so it appears that they all fly to the back of the ship. So really cool scene, amazing scene. It's fantastic, and even if you haven't watched The Expanse, it's worth just looking up that scene. I'll try to find a link if I can find it on YouTube or something, just for that couple minutes, because it's just awesome. Now another thing, it is really good. Another thing that they talk about, just with that inertia, I want to mention that this is what centrifugal force is. So most people remember that there is centrifugal force and centripetal force, and centrifugal force is fake because there's an F in it. That's all anyone remembers. But centrifugal force is objects wanting to stay in the same position. When we turn in a circle, we are turning here, our bodies are pulled opposite, because our bodies want to keep going in the same direction. So our body's wanting to keep going straight, but the car is moving away from us. So even though the Rocinante with the loose tools is turning, it's not necessarily just turning in a circle, it's accelerating and bouncing all over the place because it's in space battle, the tools are essentially experiencing centrifugal force. It looks like they're being pushed in a direction. They feel, but nothing is pushing the tools. They just want to stay where they are. And so that's why it's a fake force, because it's not, the tools aren't being thrown in a different direction. They're just like, I'm just staying here and you guys are moving around me. So I'm going to fly this way and then I'm going to fly this way. Nothing's pushing me. It's just the appearance of a force. That's why centrifugal force is a fake force, because nothing's pushing the tools. They're just trying to stay where they were because of inertia. I taught a lot of physics today. So we learned about position, speed, and acceleration and jerk. We've learned about artificial gravity. We've learned about fuel efficiency. And we've learned about inertia and centrifugal forces. That's like easily 3 weeks worth of Physics 101 class. So you are welcome. All taught through the Expanse. I mean, that's pretty much it. There's some cool scenes. The show is very consistent in the sense that they do have they don't lose the vision of being in space. So when, for example, once they get the Razorback, it all turns out okay. Once they get to the Razorback and the UN ship has been, they don't blow it up, they just decommission it by blasting the engines off of the back. No one gets hurt. It's all good. But once they catch up, once the Razorback and the Rocinante catch up to each other, now they're not accelerating, especially relative to each other, so they are in 0G. They might still be moving through space, but they're moving at the same speed. So there is still 0Gs, and because of that, Bobby is able to just carry Avasarala horizontally to the Rocinante. And again, really cool scene from that. Another sort of offhand observation was when the missiles detonate outside of the ship, so they're not hitting the ship, the missiles in the space battle are crashing into each other and then detonating, you still get sensor blips on the ship, and that would be from an EMP. So these missiles aren't necessarily just giving off an electromagnetic pulse, but when they do detonate, they send out a burst of electromagnetic radiation, which interferes with the electronics on the ship, which is valid. And that's exactly what would happen. So yeah, 2 excellent Expanse episodes. Thank you for hanging out with me. If you haven't watched The Expanse, go do it. I do have, I struggled with the first season a couple times. Everyone was recommending that I need to watch it. I struggled with the first season a lot. I did a bit of a cardinal sin and just watched a recap, like a 15-minute recap of the first season, so I could just get to season 2, and I could not stop watching it. And especially the one we talked about, the paradigm shift episode, that was when I was in full binge mode of like, next episode. So I couldn't stop after that. But anyway, I hope you all are doing well. Thank you for spending an hour with me talking about physics in the Expanse. We are currently voting in the patrons for next week's topics, so if you want to check it out, there are links down below. You can also find my YouTube channel if you want to point people to this discussion, or if you missed part of it, it will be uploaded in a couple hours later this evening. But I really appreciate everyone hanging out here. Please take care of yourself, be well, stand up, stretch, go grab some water, grab some dinner if it's that time for you. Remember to eat. Love each other. Be kind. All right. Well, thank you guys so much. I really appreciate you hanging out with me. I will be back Friday at 1 o'clock Pacific time for our astronomy club. So if you have, that's just pure astronomy. So if you have any astronomy questions that you've ever wanted answered, then please feel free to send those my way, and I will be sure to get to those. So thank you guys so much. I really appreciate everything. Yeah. We all could have. But we can use it now. So awesome. It was nice to see all your friendly faces. I really appreciate. And yeah, good luck with that. All right. Be well, guys. We'll talk to you later.